Okay, so we are live. Hi everyone, I'm Nancy, and today I'm with my friend Chayanika. So we have worked together in my first organization, which was Grofers, and now it's Blinkit. Just a sec. Yeah, I'm so sorry for the hiccup. So I have worked with Chayanika in my first organization, which was Grofers, and now it's Blinkit. And we worked on different services, and that's why I think Chayanika is the best person because she has worked with so many e-commerce applications. And so for today's topic, she's the best person. But now I'm going to leave it to Chayanika for her introduction. Over to you, Chayanika.
Hi Nancy and hi everyone. Thank you for having me on this live stream and I'm going to today talk about how cloud native helps e-commerce business scale. So before going into the talk, I would like to introduce myself. I am Chayanika. I am a backend developer with an experience of 4 years. I have been working with three e-commerce startups in India, which are very famous. First being Blinkit, and at Blinkit, I learned a lot about e-commerce tech and worked on various services like the order management system and other systems as well. And there, I met really amazing people like Nancy, and then I moved on to work with Mintra, which is also a very famous startup in India, e-commerce startup, and it is very stable and serves huge traffic volumes during sale. And currently, I'm working with Zepto. Zepto is a 1 year old e commerce startup which started during COVID, and it's still in the phases of scaling, and systems are being built from scratch. So, I have seen every phase of e commerce in India and
Yeah.
about e commerce tech.
Yeah, and I think like today's live stream is special because I've worked as a DevOps engineer and Chanika worked as a backend engineer in the same team in the same organization. So we kind of have an idea that how what are the problems which come in the on call and what happens when your application is not working and what can we do and how things what we need. So I think this live stream is really useful for folks who are working as an engineer and they would know that how to scale their applications. So over to you, Janika. Let's get started.
Yeah, sure. Let's get started on this. I would like to present. Just give me a minute.
Sure. So in meanwhile, if anyone has any question, they can just drop in the comment section. So we are just going to pick that up like after Janika's presentation. And yeah.
Yeah. So, hi everyone. Can you see my screen? Nancy, can you confirm?
Yes, yes, it is visible, Janika.
Sure. So, yeah, today I'm going to talk about how cloud native helps e commerce scale. So, let's first start with what is an e commerce? E commerce is a platform for customers to come online and buy different kinds of products. It can be very bulky products and it can be fashion goods, it can be different kinds of products. So, e commerces enable and give customers the platform to come online and visualize the products, see the products, and see recommended products for it, and apply different kinds of offers and coupons that different brands are providing. So that's an e-commerce. E-commerce gives the ability to for customers to come onto the platform, then place an order, and then customers can see the different phases of an order. If an order is confirmed, if it's delivered, or if it's cancelled. So customers should have the visibility of an order. So that's e-commerce. Coming to e-commerce systems, how are tech systems in e-commerce built, and what are the systems that enable an e-commerce? So coming to an e-commerce, what does a customer see? A customer opens and sees the home page. Then customer can view different kinds of products. That's the product listing page and the product display page, which describes the product, and it lists different kinds of products that when a customer selects a product and adds to the cart, then comes all the back-end flows that an e-commerce involves. A customer can add different kinds of products to their cart, then click on place an order. They would be redirected to the payments page. Then as soon as the payments page is done, and there should be a decrease in inventory of that product, and also that order should get created in the order management system, which is the source of truth for the order, which maintains the state of the orders. And then that order should reflect with the merchant who is selling that product. And if a product is not serviceable for a particular pin code, it should be shown beforehand itself that this product is not available. So all of these systems together comprise the e-commerce ecosystem, and these are the back-end systems. Now, what are the functional and non-functional requirements for an e-commerce system? An e-commerce system should be highly scalable. So e-commerces are continuously working to achieve that. Like they are constantly advertising through different social media platforms and through SMSs, through calls, that their sale is going live and this product is available at a very huge discount, like 80% discount, and they keep engaging customers to come onto their platform. And when that customer base is achieved and when that traffic volume is coming to the platform, the e-commerce system should be able to scale. It should not happen that customers are coming and the pages are not loading. So that's not acceptable by any customer in today's day and age. So high scalability becomes an important criteria. Now comes high availability. So when I talked about how e-commerces are continuously trying to bring in more customers to the platform, so when those customers are coming to the platform, they should be able to order, they should be able to view different products and able to see recommended products. So if any of the APIs or any of the systems are unavailable, that actually results in bad customer engagement, and customers can drop off. That can lead to order value drop off, and there can be other repercussions as well, like there can be social media bad reputation about that company, that this is not working. And there are so many e-commerces that now customers are ready to drop off and go to any other e-commerce. So high availability of e-commerce systems are very, very important. Now comes cost optimization. So e-commerces continuously strive towards cost optimization in terms of tech. Like why so? Because tech is not their main product. They're using tech to build a platform where customers can come and place an order. They're generating revenue from that order placed. They're not generating revenue from the tech product. So they want minimized cost on tech, but increased number of orders. So here comes cost optimization in e-commerce tech. Now comes efficient change management. So as an e-commerces are continuously engaging with customers. They are showing Facebook, Instagram, or other social media app ads so that customers come onto the platform. So when they notice that there are analytics on all of the pages, that how this feature is performing, how that feature is performing, so there's a continuous need for increased customer engagement. If something is not working, e-commerces want to quickly remove that and change that. So there comes efficient change management. So e-commerces want their developers to be very speedy in deploying and making that change. So here comes efficient change management. Now we will look into how cloud native technologies help here in achieving all of this. So till now, any questions we have, Nancy?
Yeah, I think Chayanika, you can go ahead. I just want to say that someone is really they said that thanks for sharing this. So yeah, I think you can just keep continuing.
Sure, thanks. So here comes cloud native technologies and how cloud native technologies help e-commerce scale. So, as I said, they're continuously trying to bring in more customers onto the platform. So, especially during sales, when an e-commerce is providing some product at a very good offer or at a very good great discount, so that's when customers go on coming to the platform, and the traffic volume increases. So there comes auto the requirement to scale up the resources. So either there's this option that you keep increased resources. So suppose you are estimating that 1 lakh users per minute is the load that I'm going to expect today. So I need these number of I need suppose I need 8 instances, so you can keep those 8 instances running the whole day. Or when the traffic increases, that's when you suppose you were running 3 instances earlier, because that was how the current traffic was being managed, and now your need is 8 instances in the evening. So you can quickly, when that traffic increases, you can scale that time. So scaling on demand is a very important requirement in e-commerce, and auto scaling enables that. E-commerce Most of the e-commerce businesses use auto scaling. I've seen some of them scaling in advance to prepare for things like sale, but some of them are using auto scaling most of them are using auto scaling to achieve this scale on demand. As and when the traffic is coming, you increase the resources, and when the traffic is not there, you decrease the resources. The business as usual is a term in e-commerce where you keep a certain number of instances for regular businesses, and when sale comes in, you can scale up on demand. So, how Kubernetes helps in auto scaling? So, moving to Kubernetes helps in auto scaling. Like you can configure auto scaling on very granular controls like CPU and memory utilization. You can say, suppose you can configure that if three of your pods are running at 60% CPU utilization, you want to scale up. You want to scale up to 3 more. You can configure that also in Kubernetes using horizontal pod autoscaler. So you can have granular controls like CPU, and there's also memory utilization. So these are being used by e-commerces to scale. When the traffic increases, your CPU and memory utilization will automatically increase, and there comes your if you want to scale up, the scaler will see that there's an increase resource utilization and increase the number of instances running. So yeah, that's how high scalability is achieved through tools like Kubernetes. Now comes high availability. So high availability is very important in regular business functions, as well as very important during sale too, because during sale the order number increase, the order what is the value of order, that also increase. So I have taken an average order value, and I have taken the average order per minute of an Indian e-commerce. So recently Mintra achieved these numbers, like 8,000 orders per minute and an AOV of rupees 2,000. So any 1 minute of unavailability for all of the any of the e-commerce system is approximately equal to 2 crore of revenue loss. And on top of that, there will be bad social media reputation and whatnot. Customers will say that this isn't, and today there's social media and customers love to complain, and there will be CC escalations for these. So high availability is a very important requirement, especially during sale when e-commerces are generating revenue. So how does these e-commerces achieve high availability? One of the major and very important feature is having rolling updates. So you don't move traffic until your pods are your new pods are available to serve those traffic. So Kubernetes offers this feature called rolling updates, where v1 and v2 pods are running at the same time, and you are slowly moving traffic from v1 when v2, when one of the v2 pod is up, you are moving traffic from one of the v1 pod to that, as you can see in this animation. So these enable deployments without any downtime, so your system is available all the time, even when you are deploying some fix or you're deploying some change, customer is not affected. Now comes there's also a feature called self healing, which you can use. You can have constant health checks to see if if any of your pods are down, then you can easily bring up another pod. So Kubernetes does this very easily. It's called auto rotation, and you can configure that if your error percentage goes above 1%, you should increase the number of pods. So auto rotation is very easy in Kubernetes, and self healing does it very well. Now comes so with self healing, your pods are never down, and you are never faced with unavailability. You can you, when one of the pod goes down, there's another pod serving request for that. Now comes when huge amount of traffic volumes come in. So that time, if suppose three instances were running when 1,000 customers were there, and the same three instances are running when there are 1 lakh customers per minute, so they can't the same number of instances can't handle the increased load. So that's when you need to scale up, and you can't afford to have your systems unavailable. So with increased load, if you are working with the same number of instances, what happens is that you face timeouts. You see that your APIs are taking time, so you can't e-commerces can't afford that. For a bad customer experience also, there can be a drop in number of orders. So auto scaling helps here. So in order to achieve high availability, you can use auto scaling, you can use self healing, and you can also use rolling updates of Kubernetes to achieve high availability, and your systems will be available all the time. And this is a very major requirement in e-commerce. Now, as I told, tech is not an e-commerce product. Tech is enabling that platform for customers to come and place orders. So orders are their main product. So they want to decrease the cost of tech involved in e-commerce system. So how does that happen? Most of the e-commerce have moved to containerization. So by containerization, what all can you achieve? You are packaging your application into a lightweight container, and you can deploy that container anywhere. You can deploy it on a shared server without information leak. You can deploy it anywhere on your QA environment, production environment, and it's so easy to use. And by using it on shared servers, you are actually decreasing the cost involved in maintaining a server. And then comes scaling up and down on demand. So you can't, as I said, you can't work with three instances when there are huge traffic volumes. You need to scale up. But when there is a decrease in traffic volume, you don't need so many instances running. That's actually over provisioning resources. If you are constantly, if your sale peak traffic is 1 lakh users per minute, but that is only the peak, that is only happening once. You can't have all of those instances running throughout the sale. It can scale up when the traffic increases, but you can't have it all the time. That's when you are actually wasting money. So e-commerces try to cost optimize here by scaling up and down on demand. And there's also this going cloud native enables e-commerce to avoid having expensive hardwares and maintaining an infrastructure. So that is tedious as well as very costly too. And Now comes from a developer perspective. You want to release something, you want to test something, so there are so many engineers involved in the development cycle. There's somebody writing the code, there's a test engineer who is testing the entire code, and in an e-commerce there is a importance of integration testing, because all of the flows involved in order checkout or in PDP, product display page, your recommended products should be available, and you should be able to see product information as well. So that involves a lot of integration testing. So if an engineer is assigned for that testing, and there is another engineer to release deployments, so that involves a lot of manual efforts, manual intervention as well, and there can be human errors. But most importantly, if you're automating releases, like if you have a release branch and any change that goes into that branch, immediately it's deployed with all of the test pipelines in place, all of the integration testing pipelines in place, then your process is also smoother, and you are saving up on two engineers their time and their cost. So that is what e-commerce is leveraged. They have built test pipelines which around order checkout flows, and also around home page and product display page, and also some of them are automating release cycles as well. Like as soon as there's a change merged to the release branch, it is deployed on the production environment after it's successful in QA, and all of these are part of the release cycle. And this is how cost optimization works in e-commerce. So mainly they save up on auto scaling, they save up on not having to maintain hardware infrastructure, and also by automating release cycles and test pipelines. Now coming to the last but not the least, e-commerces need to change very frequently because they're directly dealing with customers, and customer experience is very important. Today our customer, if you're showing some brand which customers do not like today, can actually lead to drop in customer numbers. So change management, like quickly able to change homepage, or quickly able to change how orders look like in your customer app, is a very important requirement, because there is always analytics showing that okay, this is performing good. If you show this brand, then there's a huge revenue generation. If you show this product under this product, customers are really liking it. So there's always changes involved in e-commerce. So efficient change management, and it becomes handy. So developers should be able to make changes to the e-commerce very fast. And there comes containerization. As you know, containerization and how Docker works is, if you're adding something to it, it won't build the entire thing. It will just pull in that part of the code, or build that part of the code only. So it's very, it will take smaller amount of time, and it will be very lightweight, and it can be deployed across multiple environments. Hence, easily you can make changes. Then comes things like Jenkins, which automate pipelines like deployment, scaling, monitoring, and testing. So a developer just has to develop. He does not have to, he or she does not have to think about any other thing. They just need to develop and merge it into a release pipeline, and post that everything is taken care of. You release, you merge the branch into release, your post that everything is deployed into QA and production. If everything is working smooth, then you get, if something is going wrong, then you get alerts. So that's how change management becomes easier for developers, and this is how Jenkins helps here. So yeah, guys, this is the end to my presentation. I hope you liked it. And Nancy, do you have, or the audience has, any questions?
I'm sorry, I was muted. Yeah, thank you so much, Chayanika. So that was really amazing presentation and really helpful. I go to learn a lot from your perspective. So we have questions. So we have one question, which is by Brutirith. Let's say if one instance is breached by any threat actor, then will they be able to pivot to other instances as well, or that depends on configuration itself?
So yeah, that depends on
Whether
configuration. If your thread worker is blocked and you have timeouts, then that will terminate on an instance, and you can reconfigure it to like if you send the request again, it will connect to another instance. So yeah, based on the error percentage, like how many requests have timeout, you can configure that also. Like if some requests have this number of requests have timed out, then you want to kill that instance because that's not performing out of the like up to the mark, so you need to bring up another instance.
Yeah, thank you so much for answering this, Shanika. So we have another question, but I guess the answer has already been given by him. Does auto rotation kicks in all kinds of failure scenarios? As far as I know, new pods will come up and older pods are termination due to some failure. And
Yeah,
then,
if error rates are high and if you have configured that this number of if four pods should be running at all time is the minimum number of pods running, and one of the pod goes down, then another pod will come up. You can configure that, and that is also configurable.
yeah, yeah. I think he has mentioned the limitations also, like with some scenarios which says that like high error rate or request getting blocked due to some component that is getting bottlenecked won't necessarily trigger a rotation. Yeah, I think, did you get this, Chanika? I think, Prayag, maybe you can put in more detail in the comments what you exactly mean. Is it Yeah, but anyways, like I also have a question. I think we can just continue the discussion in comments for the question which Priyag has asked.
Yeah.
Yeah, so I have a question, Chanika. Like, so I just want to mention that there was one instance which happened in which it was a very big org. I'm not going to take name, but it used to serve millions of people in different countries. It's a shopping website, and there was an incident because they didn't have like monitoring set up well, and something like the application stopped working because of so much traffic, and it costed them like a lot of revenue in just few months. So I just want to know like what was the exact
Yeah, and I think Nancy dropped off, but yeah, let's wait for her for 5 minutes.
uh, hey, hi, Chanika. Am I audible to you? Yeah,
Yeah, yeah, yeah.
yeah, I think I have a bit of network lag. Yeah, so I think I was mentioning, yeah, I was mentioning that it costed them a lot of revenue. So did you ever face a similar situation in which cloud native or setting up things properly has saved you or maybe had cost you? So if you have some incident.
Yeah, I do have an incident in mind because it really made me realize the importance of having alerts in place, having monitoring in place. So this was a scenario where I was deploying a change into one of the major services, which is the serviceability service in one of the e-commerces, and breaking that would mean a lot of customer drop offs. You can see that this pin code is not serviceable. Customers can see that this pin code is not serviceable, so they would eventually drop off from the screen. So yeah, I affected so my changes affected that service in a way. Like I when while I was deploying, As soon as I started deploying, there were 5 instances running. As soon as I deployed in 3 of the instances, the pod started coming down. It started crashing. But thankfully, we had alerting in place, and it started alerting in Slack, and we had configured Grafana to alert for any kind of crashes. So it started alerting Slack, and somebody jumped in and reverted to the previous build. So yeah, thankfully that was a savior point, that monitoring was already in place, and I could see that some of the pods were down.
Yeah, that's like amazing. I mean, it saved having proper monitoring and alerting. But I remember like even so even once I was working with Prometheus and even alerting stopped working. So I
Okay.
guess like now that happens, that's a big issue, right? So
Yeah.
yeah, due to some misconfiguration from our end. So I guess these are the few things which are super important for I think especially for an application which has a lot of traffic. So yeah, thank you so much for your answer. Also, Chanika, I have one more question. So this is kind of like because you work as a backend engineer and your main focus is developing the features and shipping features rather than getting involved in infrastructure issues or something DevOps side. So what do you suggest to people that they should focus on? Because if they start going in depth, then it will be like, it's like a rabbit hole and they can get distracted. So what do you suggest? Like, is there any limitation which you would suggest to someone who is much more interested in developing features that they should have this limited knowledge which will help them to grow? Yeah.
Yeah, sure. So a developer's job is to develop an application. But when that application ships, it is shipping somewhere in production environment. So you have actually written the code which is live there. So you should have limited knowledge of the tools that you are using, but you should have the basic knowledge, like how to things like how to scale up instances when they are going down if you're using AWS, Azure, or Kubernetes. So things like how to kill a pod, how to bring up instances. So all of these smaller things. And if you're using Grafana, how to check dashboards, how to create a dashboard. These are very basic things that developers should know, so that they can easily visualize. Suppose I want to visualize an error for errors in a particular system, and there's no dashboard for it created yet. You can wait for the DevOps guys who can write queries, and then ultimately create that dashboard and give it back to you in 1 hour. Or you can just write that query yourself and visualize it. And these are very minimal small things that you can do, like writing a Grafana query or Neuralink query, and learning how to auto rotate and bring up instances. These are very small commands and basic commands that developers should also know. So developers should know a little about the basics about the tools they are using, not go in depth. Yeah.
Yeah, or maybe I think like what they can also do is like I think this is super important to develop a culture, because like DevOps and it's in the end it's about the culture. So if you have any feedback, like let's say you are working with some application and you're not happy with the alerting or monitoring, you can always reach out to SREs and DevOps. They will be able to help because that's their primary role to help. So I think developing this feedback loop is super important as well in the culture so
Yeah,
that you can give a
working
yeah.
closely with DevOps is super important. That's how you share information. You get to know about the software you are building. The DevOps get to know about the software being built, and developers get to know about the infrastructure, little bit about the infrastructure. Yeah.
Yeah. And also, I think like you learn a lot through on-call rotations as well. So that is also super helpful in these things, which you mentioned that you should know the little commands.
Yeah, on calls
Yeah.
in e-commerce, it is very important because every e-commerce has on call schedules during sale. So yeah, working in collab with DevOps is very important.
Yeah, that is amazing. Thank you so much, Chayanika, and thank you so much, everyone, for watching it. So we do have some specific questions in the comment, which I think, Chayanika, you can, because we are running out of time, so I think you can answer that
Yeah,
later.
sure. I'll
Um,
answer that later.
yeah, but yes, this was super, super informative. And where should people find you if they have any more questions?
Yeah, they can find me on LinkedIn or they can reach out to me on the mail ID, which is displayed on the screen. So you can reach me out here.
Yeah, definitely. And I will also be sharing the updates on Twitter or LinkedIn at Women in Cloud Native channels, which is @ She Cloud Native on Twitter, and on LinkedIn you will find it by Women in Cloud Native. So we also have a Discord community where you can join, and if you have any questions, you can just ask. And if you want to see anything in future, you can just tell us. So yeah, and that is it. And thank you so much, Chayanika, for joining us today.
Yeah, thanks, Nancy, and thanks, everyone.